nonpolarity. Okay, so this only applies to covalent bonds, but in covalent bonds, electrons are shared. In a nonpolar covalent bond, the two electrons that are being shared, they're shared evenly. Due to similar electronegativities. So in a nonpolar covalent bond, the two atoms that are bonded together, they have similar electronegativities, meaning they're both equally good at pulling on electrons. So like in a game of tug of war, their strengths are equal and the electrons are shared evenly. There's not one that's better than the other. An example would be a carbon-carbon bond. Or diatomic fluorine. Those atoms have equal electronegativities, so neither one of them is better at attracting those electrons, and they're shared evenly. Got it? Okay. In a polar covalent bond, electrons are shared unevenly due to one atom being more electronegative. If we look at the hydrogen fluoride molecule, also known as hydrofluoric acid,
are you tired? Oh, she is tired.
she's.
Lulu,
You want to go?
hi. You want to go bye-bye? You want to go bye-bye? Hi. Hi. You've been resting? You don't want to learn about, what are you guys learning about? I don't think Lulu wants to learn about the mold. Okay, I like mold. Yeah, I like mold. Come on. Come on, you'll be back. Oh, yeah. Thank you. Sorry I interrupted.
You're fine. Okay, so in the hydrofluoric acid molecule, fluorine is the most electronegative, so it's more electronegative than hydrogen. It's better at attracting the electrons. So it winds up where this has more of the electron distribution than the hydrogen. And we know from ionic compounds, when one thing gains an electron, it becomes negative. When one thing loses an electron, it becomes positive. In this case, fluorine hasn't completely gained an electron. It's just almost gained an electron. So we call this a partial negative. This is the Greek letter sigma. It means partially. It's not completely negative. It's just a little bit negative, kind of negative. And this is partially lost one, so it's a partial positive. The arrow always points toward the one that's more electronegative, and it always points toward the negative. This becomes a little bit negative. This becomes a little bit positive. That's a polar bond. So here's an example I can give you. When my sister and I, you all know my sister, were younger, She's 10 years younger than me. I know you can't tell, but she is. My grandma would always give me $20 for like Valentine's Day, Easter, just random things. She would give me a $20 bill. And she would always say, share it with your sister. Well, being a grandma, she meant I take 10, give my sister 10. But she just said share. So if I had given my sister 10, that would have been nonpolar, covalent, even sharing. I was like 16. I was your age. She was 6. What did she need money for? She didn't have a car. She didn't need gas. She didn't have to buy lunch. I would usually give her 5. Nonpolar, covalent. I was getting more. She was getting less. At some point, my grandma found out, and now she gives us both a $10 bill, but whatever. And $10 doesn't go very far when you're 30. Make sense? Okay, that's all.